Welcome back. So today we're going to be working on volume of a cylinder. So you should have a foldable that looks similar to this one. You want to go ahead and take that out, and we're going to open that up. So you should have two pictures that look like this. So we have, if you remember, we talked about right and oblique the other day. So right is where our sides are perpendicular to our base already, and oblique is where it's slanted. So with our picture that we have here, we're going to start with the right. And for every cylinder, we're going to be using that same equation that we did for a prism. Volume equals capital B times H. The only difference here is we know every single time when it's a cylinder that our base is a circle. So instead of just using capital B, we're going to go ahead and substitute in the formula for area of a circle, which is pi r squared, and then times our H. Okay? And like I said, we're going to use that for both of these. So let's start with the right cylinder. So we're going to write our equation, V equals pi r squared H. And then we need to find the R and the H. So we're going to plug in V equals pi. The R for this one is 2 centimeters, so 2 squared. And then the H is our height, which is our 5 centimeters, so times 5. Okay, so now I'm going to slide this up just a little bit. So we're going to be working on simplifying this equation here. So V equals pi, exponents first, so 2 squared is 4 times our 5. 4 times 5 is 20. So we can just write V equals 20 pi centimeters cubed. That would be an exact answer. We can also convert that, to a decimal. So we're going to go ahead and approximate this one to the nearest hundredth. So on your calculators, you're going to type in 20 pi. And to the nearest hundredth, we should get 62.83, and then that's still centimeters cubed. So 62 and 83 hundredths centimeters cubed for that one. All right, so now we're going to move on to the oblique. So for our oblique, again, we're going to start out with the same formula, pi r squared h, and we're going to plug in the things that we know. We know our radius is 4, so we're going to go 4 squared, but this time we don't know the height. If you look here, we have a slanted side of 12, and we have a 60-degree angle there. So we're actually going to be working with our 30, 60, 90 triangle. So if we pull that out to the side, we know that this side is 12. We know that that angle measurement is 60. So this is going to be n and n square root of 3. This one, if you remember, was 2n. So that means n is going to equal 6, and n square root of 3 is 6 square root of 3. Okay, so our height is the long leg, that is our 6 square root of 3. Okay, we'll go ahead and shift this up just a little ways so we can focus on our equation. So from here, we're going to work with our exponents again first. So V equals pi 4 squared is going to be 16 times 6 square root of 3. So then we're going to keep simplifying so that we get an exact answer here. So I'm going to take 16 times 6, which is 96. We still have our square root of 3. We still have our pi. Okay, so that would be an exact answer, and we can put inches cubed there, or we can do a decimal approximation. So we're going to plug that into our calculators and round to the nearest hundredth again. So when you type that in, we should be getting 522.37 inches cubed. So 522 and 37 hundredths inches cubed for that one. Okay, so those are the two cylinders that we have. So that's the notes for this one. That is all that I have for cylinders. Have a great day. I'll see you in class.